If you've been struggling writing your polynomial equations, here are 6 examples that should reflect exactly what you're seeing in your assignment. And so you can just skip through to whatever problem that you were stuck on, and hopefully this gives you some guidance. So let's get started here, and just kind of a quick refresher. What our goal is to take each of these scenarios where we're given solutions and determine a polynomial function that would have those solutions. And the way we're going to go about that is we're going to take our solutions and rewrite them in factored form, which is how we found solutions previously. So we'll take the solutions in each scenario, write them as factors, and then we multiply those factors together, and we have our polynomial. Sounds pretty simple. Let's take a look at a few scenarios to see what that might look like. So in example 1, we have 2 solutions. They're both real solutions, and so I would expect to have a degree 2 polynomial equation where we just have 2 solutions. So our polynomial is going to say x squared. Okay, so in this case, we have x equals -3 and x equals 12. Those are already set up, but I'm going to go ahead and rewrite them here. It's always good to have this set up as x equals, because what we're going to do is we're going to take each one of these and write them in factored form. And so I need to make these equal 0. These equations need to equal 0. How do I cancel -3? I add. And so we get equals 0. And if I add 3 on the right side of my equation, I add on the left. Same in this other equation. I need to subtract 12 in order to cancel here and have an equation equal to 0. And so then I would subtract 12 on the other side, and we have x minus 12 equals 0. Okay, and what we've written here is a factor of x plus 3 and a factor of x minus 12 that were set equal to 0 in order to find the solutions. And so we just need to take these 2 factors and multiply them together. So for multiplication, we're going to show parentheses. So let's get that set up. We have x plus 3 and x minus 12. We'll show that we're going to multiply those together. And then for multiplication in these scenarios, it's distribution, but we might have to distribute more than one term. And so here we have an x and a positive 3 in this first set of parentheses. And both of these terms need to distribute over. So we're just going to be very systematic about it. Start with the x here and multiply it to whatever terms are in your other set. So let's take x times x to get x squared. Let's take x times -12 to get -12x. Okay, so we distributed x. Now I need to distribute the positive 3. So 3 times x is 3x. And 3 times -12 is -36. Okay, so good things to do here are pay attention to your signs. Make sure you're not making little mistakes with your multiplication. Also keep track that you've distributed completely. And there's a little trick to that. If you take 2 terms in one set of parentheses times 2 terms in another set, that should give you 4 terms overall. And that's what we see down here. An x squared, a -12x, a 3x, and a -36. 4 terms. And actually, we're all done. As long as there aren't like terms, common terms that we can combine. And you notice in the middle here, we do have 2 terms that have an x. And so we'll go ahead and bring those together. And our polynomial is going to say x squared minus 9x minus 36. Okay. So this is a polynomial equation equal to 0, and this is good enough for us. We see that the polynomial x squared minus 9x minus 36 would have these 2 solutions of -3 and 12. It's okay if you want to write them as in function notation, so it's also okay to put things such as this: f of x equals x squared minus 9x minus 36. That would technically be the function format, and that's okay as well. Your choice. So my values are different from yours in your assignment. However, the setup should be the same to where you can follow the same steps that I have. Okay, so let's look at another case here. In number 2, we have 3 solutions, and we're told that's all we're going to have. When it says degree 3 here, that means 3 solutions. That means the polynomial will say x cubed, x to the third. So let's set it up just like we did before. You have 3 solutions, and those are x values. So we'll put x equals for each of these. So x equals -5, x equals 0, and x equals 7. Okay, so let's go ahead and go through here. We want to write these in factored form. And so we'll cancel the value on the right side. We want it to equal 0. So to cancel -5, I will add, which means I'll add on the other side. Okay, you might notice this middle one already equals 0. There's nothing to do to it. And so we'll just keep it as x equals 0. So notice here, sometimes our factors have a different number of terms. It's not always 2. In this case, it's just a factor of 1 term, just x. Over here, to cancel 7, I will subtract. So I will also subtract here. Okay, so here are my 3 factors. I have x plus 5, I have x, and an x minus 7. I will write those factors in parentheses to show multiplication. And so here I have an x plus 5. Here I just have an x as the second factor, and the last factor is x minus 7. Okay, and so multiplying here, when you have more than 2 factors, you just pick 2 at a time. So I'm going to pick just these first 2, the x plus 5 and the x. So starting here, I need to multiply over. So I'll take the x in this factor times the x in that factor. That's going to be x squared. And there's nothing else to multiply to. So I'm done with the x. Now I'll multiply the 5 over. So 5 times x is positive 5x. And again, there's nothing else to multiply over in this set of parentheses. So we have accomplished that. And again, that little trick that we talked about, when you take 2 terms times 1 term, that should just give you 2 terms. And here they are. Okay, so be organized here. Realize that you haven't used the x minus 7. And so I'll show that I'm bringing that down. And we're not finished until we've multiplied everything that we can together. So I still have these 2 factors, these 2 sets of parentheses to multiply. So let's go ahead and finish that out. Start at the beginning. Take x squared, multiply it over. So x squared times x is x to the third. X squared times minus 7 is minus 7x squared. 5x times x is positive 5x squared. So keep track of your signs here. And then positive 5x times minus 7 is minus 35x. Okay. And I check one more time and I see I do have common terms here and here. They both say x squared. So let's go ahead and combine those. And we'll have x cubed. And then combining those, minus 7 plus 5 is negative 2x squared minus 35x. And we'll say that equals 0. And again, you can write it in function format if you want. Okay, so there's 2 fairly basic cases, one with 2 solutions and one with 3. So let's bump it up one more. We have worked with degree 4 polynomials, and that's what we see here. We have zeros of -3, -1, 5, and 2. So there's 4 solutions. They're all real. And so I know I have 4 solutions in total for degree 4 polynomial. I expect my polynomial to have x to the fourth. So let's go ahead and approach it the same way. We'll put x equals for each of these. And just like we did before, we'll write them in factored form. And so let's cancel where we need to make these equal 0. So to cancel a -3, I will add. So I will add here. And you might notice when I do this, my factored form just uses the opposite sign of the solution. So if my solution was a -3, my factor says x plus 3. Okay, same thing happens here. I get 0 by adding 1, and so my factor says x plus 1. Here we get 0 by subtracting 5, and so my factor will say x minus 5. And here we'll subtract 2 to get 0, and so our factor will say x minus 2. Okay. All right, so we have 4 factors this time because we had 4 solutions. And so we're going to show these 4 factors in parentheses. So let's start with the x plus 3, followed by x plus 1, and then x minus 5, and lastly x minus 2. Okay, and we'll say that equals 0 here. So the only thing different this time is we have 4 factors to multiply, but we never multiply more than 2 at any given time. So you can choose what you want to multiply first. The order of multiplication does not matter. So if you feel like a certain pair of factors are easier to multiply than others, that you could go ahead and rearrange these factors here so that you're multiplying those. But I'm just going to keep everything in order. And so I'm going to multiply the first 2 together. Okay, and let's see what we get there. We get, we're going to take x in this first factor times both terms in the other. So x times x is x squared. X times 1 is 1x, or just x. 3 times x is 3x. And 3 times 1 is 3. Okay. So we have 4 terms there. 2 terms times 2 terms makes sense. And I see that I have like terms in the middle. And so let's go ahead and combine those to get x squared plus 4x plus 3. Okay. And I said we should never multiply more than 2 at a time. And so what we can do now is we can repeat that process. We can multiply these 2 together, and then we can multiply these 2 together. At no point am I multiplying more than 2 factors. It's just I'm doing both of these multiplication steps in the same step. So let's go through this as well. X times x is x squared. X times -2 is -2x. -5 times x is -5x. And -5 times -2, I'll make sure I put +10. And combine your like terms. Common terms in the middle will give us x squared minus 7x plus 10. Okay, and so by doing that, we've gone from having 4 factors down to 2 sets of parentheses instead of 4. And if we can just multiply these together, we will be finished with this example. So going through here, multiplication steps work the same. You just distribute, keeping track of how it's going to work. I have 3 terms in this set of parentheses. I have a trinomial, and we're going to multiply it with another trinomial. So 3 terms times 3 terms is going to give us 9 terms through distribution. So start at the beginning. Start with the x squared multiplied over. X squared times x squared is x to the 4th. X squared times minus 7x is minus 7x cubed. And x squared times 10 is 10x squared. Okay, so let's now distribute the 4x. 4x times x squared is going to be 4x cubed. 4x times minus 7x is minus 28x squared. And 4x times 10 is 40x. And then we need to distribute the 3. So 3 times x squared is 3x squared. 3 times minus 7x is minus 21x. And 3 times 10 is 30. Okay. And so in this case, we just need to combine like terms. I have 9 terms written out. I can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's put together what we can. Starting with our highest exponent, we have x to the 4th. It is the only term that has x to the 4th. And so we're good there. Okay, so then we shop around. We look for other terms. And so we see that there's an x cubed term here and over here. And so we'll put those together. Minus 7x cubed plus 4x cubed is going to give us minus 3x cubed. Okay, let's go a little farther. We have an x squared term here, and an x squared term here, and also an x squared term here. So we need to be careful there that we're finding all of them. Combine. 10 minus 28 is negative 18. Plus 3 is negative 15. So we'll put negative 15 x squared. And then we keep going. We see there's a term with an x here and another term with an x here. And that is going to give us 40x minus 21x. That's positive 19x. And then lastly, you see we have this positive 30 at the end. And there's the polynomial. This particular polynomial, degree 4, would have the 4 solutions that we started with. Negative 3, negative 1, 5, and 2. All right, so let's look at another case here. Starting to get into complex solutions that have imaginary values. 8 minus 2i. Now the approach is the same. You show that this is an x value. But we had a rule for imaginaries. It's anytime you have an imaginary, you should also have its counterpart called the conjugate, meaning you should have both the positive and the negative imaginary value. So if you have a negative 2i and 8 minus 2i, you should also have a solution of 8 plus 2i. And this is always going to happen because of our rules with square root, which creates a positive and negative solution. Okay, so if these are solutions, we'll work with those, and those look like our only 2 given. So this is a case where we have a solution that has 2 parts to it, an 8 and a minus 2, an 8 and a plus 2i. But the approach is the same. We need to cancel here. We want this to equal 0. So how do you cancel a positive 8? Of course, you subtract. And how do you cancel a negative 2? You would add. So we'll subtract 8 and add 2i, meaning we'll do the same on this side. And we get x minus 8 plus 2i equals 0. Okay. And then same here. How do we cancel 8? We'll subtract. How do we cancel a positive 2i? We subtract. And that would mean we would do the same thing on this side. So we get x minus 8 minus 2i equals 0. So here's a case where you see the factors that we have more than 2 terms. And factors can have as many terms as we need. In this case, they each have 3. Okay. You also notice in these factors, the imaginary parts have opposite signs. We have a positive 2i in this factor and a negative 2i in the other. Okay, so if those are the factors, we'll write them in parentheses, showing that we can multiply them together to get back to our polynomial, which is exactly what factors are. They are amounts that multiply back to a given value. And the multiplication works the same. So let's start at the beginning. X will distribute over, so x times x is x squared. X times minus 8 is minus 8x. And I think I'm going to run out of room here, so let me rearrange. All right, that's better. Still need to take x times the minus 2i, and so we can just put a minus 2ix on that. All right, let's go to the negative 8 and distribute. Negative 8 times x is negative 8x. Negative 8 times negative 8 is a positive 64. And negative 8 times negative 2i is positive 16i. And we need to distribute the positive 2i. So 2i times x is positive 2ix. 2i times minus 8 would be negative 16i. And 2i times a negative 2i, that's going to give us a negative. And remember that I times I is always I squared. Okay, so there are 9 terms that we just got through multiplication, which is what we'd expect when we take 3 terms times 3 terms. And of course, there's going to be terms that can be combined. However, if you're looking, you're going to notice that we have some terms that have imaginaries, and they will cancel each other. So check out this minus 2ix and this positive 2ix. They're going to drop out. They are direct opposites of each other. And the same thing happens with the positive 16i and the negative 16i. They're opposites of each other, and they will cancel each other out. Okay, and so let's keep going here. For this scenario, we have an x squared in the beginning, which is what we'd expect if we had just 2 solutions. After that, let's see here, we have a minus 8x and a minus 8x. Go ahead and put 3 lines under these. And those are the only ones that have the letter x. And so we have minus 16x when we combine those. And then we have a positive 64 and a minus 4i squared. Okay. Now you might notice we've never had a polynomial that has an imaginary as one of its terms. And we won't start now. We shouldn't ever have a polynomial that has the letter I within its terms. And so what should happen in your multiplication process is all these terms that have an I should cancel. If not, something went wrong. But I squared, if you remember, is equal to the number negative 1. So let's make a little note of that again. I squared equals negative 1. Okay. And so what that means for us is working with this polynomial where we have the minus 4i squared, it would really be a negative 4 times a negative 1, which would turn into just a positive 4. And so we have x squared minus 16x plus 64 plus 4. And then if we combine those last 2 terms, we get x squared minus 16x plus 68. And so there's a polynomial of degree 2 for our 2 solutions. And, better put an x there. There are no imaginary terms to it. Okay. So using that I squared equals negative 1 is helpful, and also remembering that our polynomials don't have imaginary terms is helpful as well. Okay, 2 last scenarios here. They involve some imaginary answers and maybe some real ones too. On the back side, we see we have solutions of 2 and negative 11i. And so let's go ahead and work with that. We have x equals 2 and x equals negative 11i. And as we said before, if you have imaginary answers, you should always have the counterparts to them, the conjugates, we call that. And so if we have a negative 11i as one solution, we should also know that there's a solution of just positive 11i. And let's go and work with these. So 3 solutions, we should have a degree 3 polynomial at the end. So to cancel the 2, we'll subtract. To get 0, so we'll subtract over here. To cancel the negative 11i, we need to add. And so we need to add over here. And we get x plus 11i. And to get the to cancel the 11i, we need to subtract. And so we need to subtract on the other side as well. And we get x minus 11i. And just like we said in the last example, the factors that you get should have opposite signs on your imaginary terms as well. So we have 3 factors: x minus 2, x plus 11i, x minus 11i. Let's go ahead and work with those. Write your factors in parentheses, showing multiplication. Okay. And here, if you want to take the best route possible, do not multiply real terms with imaginary terms, factors, that is, real factors and imaginary factors, if you can avoid it, which you should be able to avoid it. And if we look here, we have these 2 factors that have conjugate values. And so we should really be strategic here and decide to multiply these factors together first. So let's not use the x minus 2 just yet. Soon. Let's see what we get here. So we get x is going to multiply over. So we get x times x is x squared. And then x times minus 11i would be minus 11ix. And nothing else to distribute to, so we move to the 11i here. Multiply over. 11i times x is positive 11ix. And then 11i times a negative 11i is negative 121i squared. Okay. And so let's check this one out, combine some like terms where we can, and we see that there's a minus 11i and a positive 11i. That x, that'll cancel each other. And so we're left with x squared minus 121i squared. So let me go ahead and fix this a little bit. We get x squared minus 121i squared. And let me move the x minus 2 down a little bit lower, because again, we haven't actually used that yet. Okay, so we're at the same spot we were before. We still have the letter I, but once again, just a good note to keep in mind, I squared is equal to the number negative 1. And so let's fix this. We'll now have x minus 2 times x squared. And since this means negative 121 times negative 1, we just get positive 121. Okay. And so there's our 2 factors, no more imaginaries. Let's distribute like we have been. X will multiply over, so x times x squared is going to be x cubed. X times 121 is positive 121x. Okay, and then we multiply the negative 2 over, and we get negative 2x squared. Negative 2 times 121 is negative 242. And again, that little check, 2 terms times 2 terms should give you 1, 2, 3, 4 terms. And your polynomial is perfect as long as everything's in order. So you do see there's a little switch here in the middle. We have x to the first followed by x to the second. And we would like for that to be reversed. So let's start with our x to the third, but put the minus 2x to the second after that. Then we can put our plus 121x and end with the minus 242. And there's a polynomial of degree 3 for our 3 solutions. Okay, last case here. We have solutions of positive 12i and 12 minus I, and these are two very different solutions, right? This is just a one-term solution, and this is a two-term solution. Okay, so let's keep track that these are actually different from each other. So let's go ahead and start with this. We have x equals 12i, and anytime we have imaginary answers, we know it's a guarantee that you will have both the positive and the negative. So I can automatically put that negative 12i should be a solution. After that, we have x equals 12 minus I, and that would mean that we should have the positive imaginary solution as well. So 12 plus I would be our fourth and final solution here. And so we have four solutions. We're going to have a degree 4 polynomial. So let's go through the same steps that we have been. To cancel 12i, we need to subtract. And we get x minus 12i equals 0. To cancel a negative 12i, we need to add. And we'll get x plus 12i equals 0. Okay, two terms to cancel here. Just go slowly. To cancel 12, we need to subtract. To cancel a minus I, we need to add. So we'll subtract 12 and add I. And that's going to give us x minus 12 plus I equals 0. And very similarly here, we need to subtract 12. And then subtract I to cancel these. And we get x minus 12 minus I equals 0. So again, it's not the real parts that are opposites of each other. It's the imaginary parts that have to be opposites of each other. Okay, and you have four factors. Let's go and put those in parentheses. X minus 12i, x plus 12i, x minus 12 plus I, and x minus 12 minus I. Okay, a lot of imaginaries going on here, a lot of room to make some mistakes, and it's going to take some room to finish this. So just go slow, be careful, and everything should turn out all right. But we never multiplied more than two together at a time. So let's put focus on opposite factors, conjugate factors. These two should cause a lot of imaginary stuff to cancel away. So let's multiply those. We'll take x, multiply it over. X times x is x squared. X times 12i is plus 12ix. Negative 12i times x is negative 12ix. And negative 12i times positive 12i is negative 144 I squared. We notice in the middle, these terms cancel each other. And so we get x squared minus 144 I squared. Remember, I squared is negative 1. And so this is negative 144 times negative 1, which is plus 144. Okay, there's our first factor. Now, we can also multiply these other two factors together. It's getting a little scrunched, so I'm going to change the color here. Let's multiply these factors together as well. And so when we do that, we're going to take x times x to get x squared. X times negative 12 is a negative 12x. X times negative I is negative ix. Now when you multiply the negative 12, so negative 12 times x is negative 12x. Negative 12 times negative 12 is positive 144. And negative 12 times negative I is positive 12i. Okay, and lastly, we need to multiply the I over here to the other factor. So I times x is positive ix. I times negative 12 is negative 12i. And I times negative I, that's negative I squared. So let's go ahead and combine terms here. We have an x squared at the beginning. But in the middle, we're going to notice that there's a minus ix and a positive ix that cancel. And also a positive 12i and a negative 12i. And so that gives us x squared minus 12x. Oh, let's back up. We have two terms in the middle that can combine. And so we have a minus 12 and a minus 12. So that's going to give us minus 24x. And then we have a plus 144 minus I squared. And I'm going to go ahead and move this down just a little bit so it's not so bunched together. So let's continue. We have plus 144, and we have the minus I squared. But again, we recognize that I squared is equal to the number negative 1. And so, because of that, we can rewrite that second set really quickly here. This is still x squared plus 144. And over here, we have x squared minus 24x. This is going to end up being positive 144. And then this is minus I squared, which it really means minus negative 1, which will give us a positive 1. And combining those one more time, we get x squared plus 144 times x squared minus 24x plus 145. So let's go ahead and finish this out. We just need to multiply these together and we're all done. So start at the beginning. X squared multiplies over. X squared times x squared is x to the fourth. X squared times negative 24x is negative 24x cubed. X squared times 145 is 145x squared. Now we take 144 and multiply it. So 144 times x squared will give us 144x squared. 144 times negative 24, numbers getting a little big here. So we just grab a calculator in those times and we get a negative 3,456 x. And then 144 times 145 is positive 20,880. Which again, it doesn't matter how big the numbers are. That just happened based off of this example. Calculators help us along the way. Okay, so if we have like terms, we need to put those together. Let's check this out. We've got x to the fourth in the beginning. So we'll keep that. And then we check for x to the third. We have a term here. And looks like that is going to be it. So, okay, so we just have the minus 24x to the third. Now we'll check for x squared. So let's see. We've got 145x squared and 144x squared. And that's going to give us positive 289x squared. And then nothing else combines. So we still have our minus 3,456x and our positive 20,880. as the constant term. And after that, we are all finished. So a little bit of work, a little room for mistake, but hopefully if we're careful, that's as bad as it's going to get, and we don't have to go back and fix very much. Okay, so use this to help you along the way. If you get stuck on anything in particular, come back to these examples, see what happened in each of these cases, and mimic the same process with what you have. With any applications that you've seen at the end, go back to your notes or view the examples online, or just wait until you're in class and you can ask your teacher. All right, good luck.